Hi everyone, today I will revise with you some past paper questions may be expected for your coming SBQ. Most of the questions will be about the thermochemistry, enthalpy of reaction, some important definition like specific heat capacity, standard enthalpy of composition, standard enthalpy of formation, and so on, and we are going to practice some problems. We have here a multiple choice question. Which of the following is a combustion reaction? If you are given the word combustion, so you should think about burning something, and burning happens in presence of oxygen. So you are going to choose the one which has oxygen as a reactant. Here we have oxygen as a reactant, so this will be the only possible answer. Very simply, when you look at this question, you need to look at the graph. Here is the reaction progress or the pathway of reaction, and on y-axis we should show the potential energy. Suppose you are giving it in kilojoule per mole. Here are the reactant sides, and on the other side we have the product sides. If you look at the heat content, so you can predict that the heat content or the enthalpy of reactant is less than the enthalpy of product. And this means that the reaction should be, yes, endothermic reaction. In any graph, when you see the enthalpy of the product is higher than the enthalpy of reactants, this means that an amount of energy should be added to the system in order to form the product. And if an amount of energy is added to the system, this means that energy will be taken out from surrounding, leading to decreasing its temperature. So the reaction will be endothermic. Remember that we are measuring the temperature of surrounding, not the system. So if the temperature of surrounding falls, this means that an amount of energy taken from surrounding and added to the system. And this happens only if the enthalpy product is higher than the enthalpy of reactant. And the delta H for this reactant will be the difference in enthalpy between reactant and product, which is here 40 kilojoule. Remember that the B here in the graph shows, what does it show? Yes, exactly, it showed the activation energy. So the activation energy here equals 100 kilojoules. EA equal 100 kilojoules, because this is the energy taken by the reacting molecules in order to start to react at possible collision. And here is the site of the formation of activated complex. X doesn't mean anything, it's nothing. Okay, also D and E, both of them have the same value, but the energy change is from reactant to product. So here is a correct answer. Now, if you read the question, this reaction is endothermic and the enthalpy change should be only 40 kilojoules. The forward reaction is, and the reverse reaction, because it has, let's draw the energy diagram for the forward and reverse reaction to discuss this problem. Here are the X and Y axis. It should be labeled. Here, as we said, is a pathway of progress or progress of the reaction, pathway of reaction. And here is the potential energy in kilojoule per mole. If we need to draw the forward reaction is exothermic, we will draw something like this. Keeping in mind that here are the reactants, here are the product, and this part here I have the activated complex. We are thus said that in exothermic reaction, the graph should be going down because the energy of the product is, or enthalpy product is less than enthalpy of reactants. And the energy required to break bond and make the molecules of reactants start to react on collision, we call it activation energy. Here is the value of activation energy. We will give it a symbol of A. So A is the activation energy for the forward reaction. Suppose this value here is 150 and here is 200 and here is 50 kilojoules. So the activation energy for the forward reaction equals, yes, from 100 to 50 equal 50 kilojoule per mole. Number 2. What is the enthalpy change for the forward reaction? The enthalpy of products equal, as you can see here, 50 kilojoules, and the enthalpy of reactants equal 150 kilojoules. So enthalpy change for a forward reaction, for this forward reaction equal minus 100 kilojoule per mole, which is consistent with what we expect because it's an exothermic reaction graph. Remember the formula: enthalpy change of the forward reaction here equal enthalpy of products minus enthalpy of reactants. In case of exothermic reaction, this result will be negative, and it will be positive if the reaction is endothermic. So, to answer this question, the forward reaction is slower than the backward reaction or the reverse reaction. Why? Because the activation energy in the forward reaction, if you look here, it's just the distance between reactants, the enthalpy of reactant and the activated complex, which is here 150 minus 150 kilojoule per mole. And the enthalpy of the reaction, which is the difference between reactant and product, equal 50 minus 150 equal minus 100 kilojoule per mole. If you need to calculate the activation complex or the activation energy for an endothermic reaction, the opposite reaction, when products become reactant and reactants become products, it will be the difference again between the reactants and the activation complex. Here it equals enthalpy of the reaction, which is 100 kilojoule. Remember that no negative value of energy. Negative is just a sign to show you that it's an exothermic reaction. But amount of energy which is required here is 100, and it should be written in positive. Plus 50, this part, so equals 150 kilojoule per mole. And this means that if the reaction goes in this direction, if A plus B reacts to form C plus D, and the reaction is exothermic, this reaction requires an amount of energy equal minus, yes, correct, minus 100 kilojoule per mole. If the reaction is going to be reversed, delta H doesn't change, okay, but just the sign will be different. So then what is the difference between the forward reaction and the reverse reaction? The difference is only in the activation energy. Activation energy in the forward reaction here is much small, it's just 50 kilojoule per mole, while in the reverse reaction equal 150 kilojoule per mole. So the activation energy is much higher in the reverse reaction. So to answer this question, the forward reaction is slower. Why is it slower? Because the activation energy is much smaller, while the reverse reaction, it has a higher activation energy. let me stress more on the activated complex, activation energy, enthalpy of reactant and product for the forward and for the backward reaction. Remember that activation energy of the reaction is the amount of energy required by the molecules of reactant to collide to give a successful product. So the molecules of the reactant must gain an amount of energy. Those energy will be gained by the molecules in the form of kinetic energy until the energy become enough for the molecules to collide successfully, producing a useful product. So this part should be an endothermic part in any reaction. Here I will express it by A, and I will say that the activation energy for the forward reaction equal 200 minus 100 equal 50 kilojoule per mole. And then what is the enthalpy change of the forward reaction here? Enthalpy change, very simply, is the overall change in the reaction, which is the difference between energy in the products and the energy in the reactants. So it's equal enthalpy of products minus enthalpy of reactants. Enthalpy of products here equals 50. Enthalpy of reactants equal 150. So the overall change will be minus 100 kilojoule per mole. This is for the forward reaction. So this area, which I will call it B or C, it represents the enthalpy of reaction, of the forward reaction. If you reverse the reaction, some reactions are reversible. Once the products are formed, they will again break to form the reactants once more. So you're going to replace the product with reactant and reactant with product. Where is the delta H? Delta H doesn't change. Delta H in the forward reaction, it goes in this direction, and it has a value, as we have just said, minus 100 kilojoule per mole. And the delta H for the backward reaction from reactants to products, it will be the same thing but in the opposite value, opposite sign, positive 100 kilojoule per mole. So value of delta H is constant, whether the reaction is forward or backward, forward and backward. Okay, but only we have an opposite sign. In case of activation energy for the reverse reaction is the energy gained, again, energy required or gained by the reacting molecules to react and form, will be able to form a successful product. So it equals the distance between the reactants and the activated complex. Here it equals from 50 to 200, so equals 150 kilojoule per mole. What is 150 kilojoule per mole? Equal what? So delta H for reverse reaction, from where we can get it? Very simply, you will add delta H as a value, not as a sign, plus activation energy of the forward reaction. So you will get the value of the delta H of the reverse reaction. So it's very clear that the enthalpy or the activation energy in the exothermic reaction, okay, if the exothermic reaction is a forward one, the reverse reaction will have much higher activation energy. If more energy is required, so this means that the backward reaction or the reverse reaction will be faster than the forward reaction. because it requires more activation energy. Now we will be more confident when we answer this question because now we understood a lot about activated complex activation energy. Let's read the question. Find the value of the activation energy of the reverse reaction from the potential energy diagram. The following potential energy diagram and answer the question below. Let's label the graph first. First, you should learn or recognize that the forward reaction is exothermic. Second, activation energy of the forward reaction equals 100 minus 40 equals 60 kilojoule per mole. 3. Enthalpy change of the forward reaction, which is the distance between reactants and products. 40 minus 20 equal 20 or minus 20 kilojoule per mole. If the reaction is going to be reversed, so the activation energy for the reverse reaction should equal all of this distance, which equal activation energy of the forward reaction plus enthalpy change of the forward reaction. So it equals 100 from 100 to 20 equal 80 kilojoule per mole. So the answer is 80 here. What is the activation energy of a reaction? Explain how this energy is related to the formation of the activated complex. Activation energy is the minimum amount of energy needed to make a reaction take place. The minimum amount of energy needed or required to make a reaction take place, and this happens when the molecules of the reactant have enough energy to collide successfully and produce a successful product. When the reactants are provided with the activation energy, the old bonds, we mean the bonds in reactants, are broken, leading to formation of the activated complex. We just said that if we have two molecules AB, if this is a molecule A and we have a molecule B reacting to form two new products, C plus D. C plus D. In this reaction, bonds in the reacting molecule should be broken to separate the atoms, and then new bonds will be formed in the product's molecule. In order for this to take place, the reacting molecule should have enough kinetic energy, and they gain this by absorbing energy from the system, and this energy, that what we call it activation energy. When the molecules gain enough energy and they're just about to form the product, they form a transition state molecules. We call it activated complex. Suppose the activated complex is something like this. It's a transition state. It's not a reactant and not a product. It's just in a state that they are about to form the product. Use the energy level diagram for rearrangement reaction of methyl isonitrile to acetonitrile to answer the following questions. So the methyl isonitrile rearranged to form acetonitrile. This is the product, reactant and product. Is the reaction represented by this diagram endothermic and exothermic? Yeah, very simply, it's an exothermic reaction. And you are asked to explain why it's an exothermic reaction. Because the heat content of the reactant is higher than the heat content of the product. Product has a negative sign, reactant has a positive sign. So heat of products minus heat of reactant will give you a negative sign. What does chemical structure at the top of the curve represent? Yeah, the chemical structure at the curve was something like this. So he is asking what is the chemical structure at the top of the curve. At the top of the curve we have activated complex. What does the symbol EA refer to? EA means, yes, activation energy. Activation energy. Why is it important to balance chemical equation? As per the law of conservation of energy, number of moles in reactants should equal number of moles in product. If you have a balanced equation, you can make a valid chemical experiment and you can make a valid conclusion about the enthalpy of reaction. So we need to balance a chemical equation. So if I say H2 plus O2 gives H2O, this equation is not balanced. I have on that side 2 oxygen atoms, on the other side 1 oxygen atom. So you cannot predict the correct amount of energy used to break or to form bond unless your equation is balanced. In order to balance an equation like this, if I have here on that side 2, I should put here 2. This makes hydrogen 4 atoms, so you are going to multiply this by 2 to make the other side also balanced. Here we satisfy the law of conservation of energy, so E will be the possible answer. What are the correct coefficients when following chemical equation is balanced? If you are balancing an equation like this, SB, I have here SB4, so very simply we should put here 4. O, 6, and here 2, 2 into 3 equals 6, and this one will remain 1. So the answer is 4, 3, 1. Which of the following correctly illustrate the conservation of mass for the reaction? Very simply, we need to make sure that mass of reactants, sum of masses of reactants equal sum of masses of products. Choose us to count and see which value is accepted. So if you calculate here mass of reactants and mass of products to see which two values are equal, here 4, 3, and on the other side I have 2. So this is wrong. For B, we have 108 plus 96, and here we have 204. You recognize that now both sides of reactant and products are equal, so B will be the correct value. During a chemical reaction, atoms are never destroyed, New substance will not be produced because they are just rearranged. Atoms are rearranged. This is a good answer. Elements are destroyed. No. Heat must be provided. No. So the one which should happen in all chemical reaction, atoms are rearranged in any chemical reaction. We have an important question here. Use the energy diagram below to answer questions A to E. Use the table below to identify what each of the following letters represent. You are asked here to represent the meaning, to explain the meaning of all of those letters. We have X, Y, Z, Q, and T. First, X. What does X mean? X is enthalpy of reactants. Enthalpy of reactants. What's Y means? Y is the activated complex. And Z, it means enthalpy of products. Enthalpy of products. Q is the activation energy. While T, the difference between reactant and product, so this is the enthalpy of reaction, delta H. Enthalpy of reaction. B, is the reaction above endothermic or exothermic? Justify your answer. Going back to the previous slide, the curve was going down like this. So this reaction is, yes, correct, it's an exothermic reaction. So it's an exothermic reaction. You can say because heat or enthalpy of product is less than enthalpy of reactants. Which reaction is favored, forward or reverse? Justify your answer. You know that enthalpy in case of exothermic reaction, activation energy in the forward reaction is, yes, less than activation energy in the backward reaction. This means that the forward reaction is much slower than the backward or the reverse reaction. So, forward reaction is favored because smaller activation energy is required. And here is the answers of all the questions we are just solved. Now we'll practice some problems on bond energy. Use bond energies to determine the enthalpy change for the following reaction. We have a reaction and you're asked to draw. First, you should draw the structural formula showing all the bonds. Then you need to use the values, the standard values of bond energy, and calculate the bond energy or the enthalpy change. Remember that the enthalpy of those reactions equal bond broken minus bonds formed. First, you need to draw the structural formula of the molecule C2H4. C2H4. If you just draw it like this, you recognize then that one hydrogen from one electron from each carbon atom is not used. Carbon is in group 4, has 4 electrons outer shell. Now 3 are shared here, and 1 electron is left from each carbon. So another bond should be drawn here. So I have a double bond here. Plus F2. F is in group 7. Each of F atom needs 1 electron to be shared. in order to be stable or octet. C2H4F2, C2H4 and F2. Now let's count the number of bonds that are formed and broken. You can separate it like this. Make this area 4 bonds broken, and here 4 bonds formed. Bonds broken, I have 4 CH bonds are broken. 1, 2, 3, 4. And I have 1 bond C double bond C. And we have also 1 bond FF. You are going to record the values as they are given here. 4 CH, and here is the value. C double bond C and FF. Just add them all and find the total of bonds broken energy, 2421 kilojoule per mole. In the other area, bonds formed. How many bonds are formed? We have CF. How many CF? 1, 2. How many CH? 1, 2, 3, and 4. And we have still 1 CC bond. Count them all. CC 3, 4, 8. Okay. Remember that C double bond C is different from CC bond energy. 4 CH and 2 CF. So the total of bonds formed will be 2970. So the enthalpy change equal bonds broken 2421 minus bonds formed 2970 equals minus 549 kilojoule per mole. From this, you can predict that the overall reaction is exothermic. You might be asked to draw the energy level diagram to show the reactants and products on the diagram. You will be able to do all of them. Use the bond energy to determine the enthalpy change for the following reaction. You are given the reaction. You need to change it into bonds. H2, H single bond H, Cl2, Cl single bond Cl, HCl, HCl, and HCl. The total of bonds broken is HH plus ClCl. You just copy their values. Bonds formed, I have 2HCl. You will copy its value, and you will find the value of delta H and recognize that the reaction is exothermic, the forward reaction is exothermic or endothermic. In this question, you are asked to determine the enthalpy for the following reaction. Methane CH4. Remember, carbon is in group 4 and has 4 electrons in outer shell. Is going to share them with 4 hydrogen atoms. O2, O double bond O, it's a double covalent bond. Gives carbon dioxide COO. Oxygen is in group 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. It's going to share 2 electrons with each oxygen will share 2 electrons with carbon. Plus water, HOH. The equation needs to be balanced in order to proceed. CH4, so I have 4 hydrogen, and on the other side I have only 2. So we'll put here 2. Oxygen 2O, and we have 2O and 1 carbon. So now the equation is fully balanced. You need just to write the bonds broken and the bonds formed. So bonds broken the total of bonds broken energies equal 4 CH plus 1 O double bond O. We'll find the value. For the bonds formed, we have 2 C double bond O plus 2 multiply 2 because I have here 2 OH bond, and because I have here 2, so we have 4 OH. You will find the total bonds formed and then write the formula delta H equal bonds broken minus bonds formed. Similarly, you can answer this question here. Just look for the bonds broken and the bonds formed. Bonds broken, we have here HO, HO times 2, I have 4 HO. OO, single bond O, we have 2, so multiply 2. On the other side, HO, HO, we have 2 times 2 HO plus 1 O double bond O. We have a completion question here. The product of reaction have an enthalpy of 458 kilojoule per mole, and the reactants have an enthalpy of 658 kilojoule per mole. What is the value of delta H for this reaction? So this is the enthalpy of the product. So write the formula first. Delta H equal enthalpy of products minus enthalpy of reactants. Enthalpy of products are 458 kilojoule. Enthalpy of reactants are 658 kilojoule. So find the value of delta H. It's very clear that it will be minus 200 kilojoule per mole. This is the value of delta H, and don't forget to write the correct formula and the correct unit. Determine delta H for the reaction between Al and Fe2O3 according to the equation, and you are given the equation. Enthalpy of formation of Al2O3 is so Al plus O2, Al plus Fe2O3 equals Al2O3 plus 2Fe. I just copied the equation. Enthalpy of formation of Al2O3 minus 1676 kilojoule per mole, and the enthalpy of formation of Fe2O3 is minus 826 kilojoule per mole. Remember that enthalpy of formation of all elements equal 0. So delta H equal enthalpy of formation of products, so sum of enthalpy of formation of products minus sum of enthalpy of formation of reactants, equal minus 1676 minus 826 equal minus 1676 plus 826, and you will get the final answer. You will get it in a negative value. This means that this reaction is an exothermic reaction. Keep in mind that this question is not coming in school-based quiz, but you may see it in the system-wide quiz. There are two additional worksheets. You can see them in the D2L. You can use them to practice for your exam. Good luck with your exams. Thank you.